You are living in the most disruptive time in human history. Given the advances in AI and biotechnology, you might have to contend with the possibility of human immortality. It's certainly not a guarantee, but advances in healthspan, anti-aging, and cellular biology make it one of the most important conversations of our time. Investments and decisions made now will reverberate for generations to come. Here to talk about the state of affairs is Dr. Bill Greene. You, as an investor, have a very difficult job. And as an investor, you have to bet against the consensus and be right. So what I want to know is, what is it that you really believe in your specialty of biotech that you're willing to bet big on?
Fundamentally, we're here to invest in people and companies and ideas that are going to lead to real breakthrough therapeutics that can treat, delay, and even prevent diseases of aging. More broadly in biotech, we're here to create the next generation of therapies that are safer, more effective, and more tailored to the actual problem that individuals have as opposed to really broad populations. And that's exciting.
How far are we going to be able to push it? So if we can slow down aging, I'm sure we can both agree on that. The question becomes, can we stop aging? Can we reverse it?
The short answer is absolutely. We know we can. In worms, sometimes in mice. Can we do it in humans? At the level of our cells, yes. Can we do it at the level of our whole body? Maybe. The question is, do we want to? What we really want to do is live our lives in health with vitality and not spend increasing portions of our lives debilitated by chronic disease. That's what most people really think about. They don't necessarily want to live forever, but they definitely want to live healthy. I do. Most of us do. And that absolutely has a role to play with the biology of aging, with slowing down the processes by which aging, if you will, goes wrong.
I'll be very eager to have the debate about whether we should want to or actually live forever. But first I want to know, so given that you're looking at this, there's a real shot that we're going to be able to, we know we can reverse it in a cell, but there's a shot that we might be able to, as we get more breakthroughs, do that at the level of the whole body. What is the bet? As you look at this as an investor, there's going to be a few things on the table that you think, okay, it's maybe one of these, and I'll make this number up, but maybe one of these 5 things. What is that small handful of things that you think have a real shot to be a blockbuster?
Some of what really leads to chronic disease and degenerative disease is fibrosis. It literally, instead of being pliable and resilient, our tissues can get fibrotic and connective tissue builds up and actually not only reduces the ability to move, but actually reduces the function. So think about your heart, which has to beat every second. If it becomes fibrosed, it can't expand, it can't relax, it can't beat strongly. And that's one of the causes of heart failure. If we could actually, and we've thought that fibrotic process is a one-way street. Once it starts, you maybe can slow it down, but you could never stop it or reverse it. If we could reverse fibrosis, we could unlock a lot of resilience in our organs and tissues, and that could actually reverse some of the diseases of aging.
Is there anything that we see in the research that's promising? Like, is somebody actually working on this?
Lots of companies are working on it. And even more encouragingly, researchers from a variety of biology perspectives are really looking at the connection between chronic inflammation and how that leads to fibrosis, and looking at that edge of how does it cross that line from I'm inflamed to I'm actually building up unhealthy connective tissue and becoming restrictive. So there's lots of research going on there. There's lots of scientists working on it. I can't say today who's going to find the exact right thing, but I'm highly confident that given the thoughtfulness and investment in research that we will have several ideas to try out as therapeutics. And one of them may well work.
How do you evaluate a company? So, for people listening that don't know a lot about biotech investing, it's had a brutal bear market the last couple of years. Some people think that maybe we're beginning to thaw out. Again, going back to the idea, you have to be able to bet against the consensus and be right. How do you look into this? Are you evaluating the entrepreneurs? Are you evaluating the science? How do you develop confidence when the world thinks you're crazy?
You have to be a little crazy to invest in biotechnology because there's so many ways that things can go wrong. And at its heart, while we study the science, we utilize the science, we exploit the science, we don't know all the science. So by doing clinical trials, by developing a drug, it turns out we discover more science. Unfortunately, sometimes that means the answer is no. So at its heart, we invest in people. It's people that make this work. It's people that figure out the science. It's people that use what they're learning along the way to go back and question their assumptions and refocus to find the right path if they find they're on the wrong path. That's a hard skill. It's a rare quality, and that's what we look to invest in. If we find those people and help those people create companies, there's a definitely higher chance of success.
What do you think about somebody like Elon Musk? So I don't know how much you know about my background, but I started out as an entrepreneur, had to learn business. And when I look at Elon, I see somebody that is a once in a generation, maybe even less than that, mind in terms of his ability to actually get something across the finish line. And I am aghast, Bill, aghast at the number of people that look at him and see a loose cannon, somebody that can't be trusted. People throw shade at him as an entrepreneur. You didn't found this, that, or the other. If I'm running my human evaluation algorithm on him, I come back, it's just all green lights, even though for sure he's going to get things wrong. There's no doubt about that. But he, from just a track record perspective and ability to process data quickly, he falls into a very elite category. But even he, despite the number of billion-dollar companies that he has been a meaningful contributor to, there are still people that discount him. So what does your algorithm look like as you evaluate an entrepreneur, and use him as an example so I can understand how you think through this?
With the caveat that I don't know Elon Musk personally, I'm inclined to agree with you that he must have a once in a generation mind, and is incredibly smart, incredibly driven, and clearly is able to organize people, drive people, and get things done. There's no question. Those traits are necessary in any entrepreneurial activity and absolutely necessary in biotech too. In addition, what's a little different about biology and biotech compared to, broadly speaking, tech is often in tech, we know the science, we know the physics. The question is, can the engineering work? Can we actually make something that will do the thing that we want to do? In biotech, we don't have perfect knowledge. We actually don't know at the end of the day whether, if we get all the science right, get the engineering right, get the clinical trials right, if it will actually work until we do the experiment in people. And that introduces a couple things that are different. One, there's a tolerance for risk and an embracing of that kind of risk that you just have to take. And we have to be data driven. We have to actually accept the fact that sometimes we learn that biology is going in a different direction than we thought. And that's a little different, and we can't just force that. We can't force or cajole that to be different. The other thing that's a little different sometimes is when we're talking about making pharmaceuticals and making biotech drugs, we are talking about people. We do have to be really thoughtful about how we design clinical trials, who we put in clinical trials. And that's just another dimension beyond pure entrepreneurship that we have to take into account. So all the entrepreneurial and brilliance lights flash green for me. Totally agree with you. In a biotech setting, you have to have all that, and then also the ability to learn from the science, um, accept that you might have to really retrench and refocus and go in a different direction, and really pay attention to how we're going to protect people as we do those clinical trials.
I think that to me is exactly, so what I hear you describing is basically first principles thinking. You have to go in, look at the data, you have to make sure that you're understanding what's really happening, you have to be willing to adjust to that. That to me, in a nutshell, is what makes Elon so fascinating, is he thinks from first principles. So when I talk to budding entrepreneurs about, how are you going to be successful, it's what I call the physics of progress. The reason I call it the physics of progress is I really believe that it is foundational. I'll lay it out, but I don't think there's anything beneath this. And for people that haven't heard of first principles thinking, it's getting beyond analogy. You're getting to the actual root physics of the situation. So progress to me happens in the following way. You're going to come up with a guess as to how to overcome an obstacle to reach your goal. So you need to know what your goal is. You need to know what's currently stopping you. Like, why will you not just automatically get to your goal? Entropy is one easy way to think about it. The world's just working against you in 1,000 different ways, whether it's biology and it's incredibly complicated, whether it's humans in a biotech setting where they're just not being compliant. Other companies that are trying to scoop you and move faster, whatever it is, there's just going to be a lot of things working against you. So you have to identify, I know where I want to go. I know what's standing between me and getting there. And I'm going to come up with my best guess on how to overcome that. You're going to need to come up with a point of data that you're going to use to determine whether you actually move towards your goal or not. And then you're going to run a test and you're going to try that thing that you came up with. And it's probably not going to work as well as you want it to, but you're going to learn in that failure. And then you're going to start over. And you're going to be a little bit more informed. You're going to come up with a little bit better hypothesis, maybe a slightly different metric by which to judge it. You're going to run that experiment. It's going to fail again. And you're just going to exist in that loop. The reason that Elon seems utterly fascinating to me, and for people that don't know, he has a company called Neuralink, and they are trying to do effectively computer-brain interfaces. So he is somebody that's very much in the biotech space as well as many other spaces. And when you hear him talk, that's his process. He wouldn't call it the physics of progress, obviously, but you're trying something, you're iterating, you're learning, you're getting your ego out of the way in order to build upon that. So if we agree that that is the only path forward, and if you see another path, now is the time to tell me. But if we can agree that that's the only path forward, how do you figure out if the person you're sitting across from is actually going to be able to do that?
Great question. And boy, I wish I had an algorithm that I could write on a 3x5 card so I could interview potential CEOs and say, got it, ABC. It's hard. And it's hard in part because no one goes to school to study how to have those qualities, that ability to be data-driven, that ability to wash, rinse, repeat, and get it a little bit better and a little bit better, and have the fortitude to be able to do it and to communicate effectively with stakeholders why we're doing it this way and why we took that step and why we're taking the next step. It's hard, and I think it's a relatively rare skill. The algorithm that I use personally is asking people about what adversity they've faced in their lives, in professional, sometimes personal, but certainly professional lives, how they worked around it, what they did in the face of failure, success.
What's the right answer to that question?
There's more than one right answer. Absolutely. The right answer that I really like is, it hurt. I was sad. I had to take a couple days and really think about, why am I doing this? But then I thought about it, and I thought, there's another path forward. What I have to do is this. What we have to do as a team is that, whatever it is. And then we went and did it. And it was hard, but we got somewhere. That's an answer I love to hear.
Now, there is a very hard reality to be faced in entrepreneurship. And in fact, let me set the stage for people. So, according to your own website, and I've heard you answer this question before, so I know what you're going to say, but according to your own website, you guys have up to $1 billion a year to invest, with the goal of making Healthspan available to everybody. That gets complicated, and I'm sure we'll talk more about that later. But the reason I bring that up now is you have a lot of money. And by biotech standards, you guys are arguably the biggest player in the space. And as the chief investment officer, you're the one that's going to have to make a call on a lot of people. And with no sort of easy answer, you have to accept that even if the person gives that answer, there is just a sense of raw intellect. And I have interviewed I've interviewed over 1,500 people, which doesn't sound like a lot unless you're an entrepreneur and you know just how many hours that is. And what I've learned is that hiring borders on impossible, and that the situation is so artificial that the only way for me to know if somebody's going to be good is to actually work with them for a while. So we ended up building in a 90-day probationary period. My default answer is no. I know what metrics you're going to need to hit for me to be comfortable moving outside of the 90-day window, but I really need to see, are you smart? And I'm looking for people that are really smart. And if you know my personal philosophy, that makes me deeply uncomfortable that that's a thing, but that's a real thing. I'm also looking at not just resilience, which is what you described. I'm looking for raw, unadulterated obsession. I'm looking for somebody that borders on mentally ill, that they are so all in that nothing is going to stop them. I'm going to guess, given your experience, you know those things to be true. So my question becomes, when you're not hiring somebody, how do you get to know them well enough to know if they're just giving you lip service in the meeting or if they really have what it takes to plow through what could be 10 years of sort of blind faith that you see something other people don't, and that they'll overcome the nigh insurmountable obstacles that are inevitably going to come their way?
Yeah, important topic. Important topic in anyone's work life, and absolutely in ours. I'm going to answer that in just a moment. A couple things about what we're doing at Hevolution from an investment standpoint that I think can be helpful. One of the challenges in biotech is, as you mentioned, experiment, fail, iterate, experiment, fail, iterate, move ever closer with each cycle to the ultimate goal is absolutely important. In biotechnology, when each of those experiments or each of those efforts is a clinical trial, it's expensive. And one of the biggest challenges, possibly the biggest challenge in biotech, is even if you're on the right path, getting more capital to do the experiment enough times to get you there is really hard. Investors are fickle. Even venture capitalists are a little bit fickle. They have to be. Your average venture capital firm has to obviously make money and needs to make money in a certain time period. It's more patient than high frequency trading, but it's not infinitely patient capital. So one of the things that we bring as impact investors into this space is the ability to support companies and entrepreneurs through more cycles, to hopefully give them the chance to succeed where other sources of capital might not initially give it to them. So that's a real intentional piece of why we have an investment function, and why we're supporting it with to the extent that we are, because we think this space, new space, difficult biology, new biology, companies need the ability to iterate more than once and to get more than one shot at success if they have the right people and the right science. And so we're here to support them for a longer period of time, if that makes sense. To answer your question about how do you get to know leadership teams and development teams of biotech companies to to both assess whether they have the raw obsession and the resilience to get there, and to help them to build more of that into what they do. It takes time. One of the things that's challenging, many things have been challenging about COVID, but being on boards during COVID is only superficially convenient because you do board meetings over Zoom. But there's a real piece that you miss by going and being with your leadership team in person, spending time with them, having dinner and lunch with them, standing around having coffee and actually talking about what they did over the weekend, what's happening at home, how they're integrating their work life, both professionally and personally. Those three-dimensional ways of understanding people are what give you the opportunity to catch them doing something right, which reinforces all the things we want to reinforce in entrepreneurs, and help them course correct if you can see something that they can be coached on.
Do you know who John Wooden is?
The coach?
Yes.
Yeah.
Okay, so John Wooden, famous college basketball coach. I don't think this is an apocryphal story, but even if it is, it's very interesting. He said he used to spill water behind a star player and then see how they would respond. He would have like the towel boy spill water, and he would see how people would respond to them. And if they were kind and courteous, then he was like, okay, cool, I know this player has character. And if they were a jerk and mean-spirited, then he was like, no matter how good of a player, I can't have somebody that brings that attitude. Is there a similar spirit in entrepreneurs that you look to see that they have the it factor that's going to help them be successful?
100%. This is, thank you for asking that question. I didn't know that story about John Wooden, but I love it. I don't provoke CEOs and biotech executives by doing something annoying and seeing how they'll respond. Although it's not a bad idea. I absolutely look for the no job is too small attitude. I love leaders who come from a service mindset. If I see a CEO making coffee for people, putting new paper towels on the paper towel roll, staying late to being the last guy out of the office, not because he's driven. I mean, yes, he or she is driven, but also because they're cleaning up from the day. I love that. I absolutely love the no job is too small attitude. And I think that leaders who come from that place empower their people to think no job is too big for them.
If there are a few buckets in front of us of what you think is actually going to push Healthspan forward, what do you have the most conviction in?
I think there's almost no question that addressing chronic inflammation as a root cause of chronic disease will yield some really interesting and hopefully breakthrough therapies. I also have a real belief that there's some next generation technologies that are going to really potentially have an impact here. And by that, I mean the kinds of technologies that can yield more than one kind of therapeutic. So getting away from one disease or one approach to disease. We've seen that gene editing is really exciting. There's been a lot of investment. First therapeutic has gotten approved in gene editing. That's good, but that, of course, that's pretty permanent. That changes your genetic makeup. We've also seen in the longevity and healthspan world a lot of interest in cellular reprogramming, actually going and taking cells and moving them back to a more youthful state. Really exciting, but also sort of a blunt instrument. You're changing the whole cell, which could have all sorts of effects, good and maybe less good. I'm really excited about what's the next set of advances in manipulating the genes in the cells that will take all the best things from those and be really applicable to the long term for broad populations, we talk about the epigenome a lot in aging. So the genome is your DNA. It's the blueprint of how you're built and what you do. The epigenome is how those genes are expressed. And there's dynamic control over your life about genes expression goes up, gene expression goes down, and there's lots of paths that the body uses to manipulate, to change that. And those controls over not are you driving a car and is it a car or a submarine, but how fast is the car going? Is your foot on the gas? Is your foot on the brake? Those kinds of processes are really important for aging. And if we could control the epigenome, if we could edit the epigenome the way we can edit the genome, we might have a more dynamic way to change the expression of cells and to therefore maybe temporarily move them to a more youthful state or only move part of the cell to a more youthful state. And that potentially could have wide-ranging impact over time. This is not an overnight thing, but over time, that sort of approach could be really important for chronic diseases. So I'm really excited about people doing fundamental research into how we can manipulate cells to get them to do the right thing in a more dynamic way.
Okay, this is really interesting. There was a recent study that came out of Harvard that took mice and I think genetic or bred them to have a predisposition to breaking in the DNA. Because the fundamental question was, is this a DNA mutation problem where, hey, you get an X-ray, you fly, you're exposed to all these things that are damaging your DNA, and aging is basically the accumulation of these mutations where we're just putting the DNA back together in the wrong way? Or is it something to do with the epigenome where as this starts to get complicated, but the way that you're marking the DNA for what genes to express is called methylation. So your genes are tightly bound up and you basically loosen parts of it to say, I'm a skin cell, I'm a heart cell, I'm an eye cell, whatever. Differentiation. The theory went that it's either all of these gene mutations in the DNA that are causing the problem, or it's the way that they are getting marked so that they're basically de-differentiating. So now instead of being clearly an eye cell, and the wrong part of it has become loose and is expressing itself. And this very clever experiment showed that even these mice, that their DNA is constantly breaking and needing to be repaired, at the end, when you looked at their DNA, it was the same. It wasn't accumulating a bunch of mutations. Instead, what was happening is that we were getting de-differentiation. The methylation, the bookmarking, to use a very layman's term that you may hate, is the problem. And so that to me makes a lot of sense that you're really excited about this. But what I want to know is, okay, one, do you think that, would you be willing to make the declarative statement that the epigenome, errors in the epigenome is aging?
Absolutely. The only caveat I'd say is that's not the only process of aging. It's not the only different definition of aging, but I believe it is a definition of aging. It is one of the processes that is aging. And when expression through the epigenome, when control of the epigenome goes wrong, that is absolutely, I believe, one of the ways that aging goes wrong and we get disease. So it's one of the pathways that's really important.
Okay, so let's go through the hallmarks of aging. I've heard you talk about something I have not heard other people talk about, which is emerging hallmarks of aging. So I'm going to guess it goes something like this. They're the things that we know and have already named, and you're going to tell us what those are, known as the hallmarks of aging, wrinkly skin being the one that everybody can see, much to my dismay. And then you've got things that we're just now discovering is what I'm guessing you're going to call the emerging hallmarks. And then I would love to, one, lay those out. And then the last part of this is understanding which of those do you think are controlled by the epigenome? And then since you're not willing to say that that is the sum total of aging, what sits outside of that?
Well, this is a great conversation, and there might be a job for you at Hevolution in our science department actually helping create that future. We think about these things. So the term hallmarks of aging refers to a set of ways, if you will, that the cell can go bad over time, in response to all the slings and arrows and insults that cells are subject to as we live our lives. Things can start going wrong. DNA can break, of course. When DNA breaks, accumulate enough and don't get repaired enough, in my mind, that sends you down the path of cancer. When the epigenome breaks, that sends you down the path potentially of cancer, but certainly of these chronic diseases and aging. But there are other ways that that cells can go bad, if you will. They can lose their ability to fold proteins correctly, to actually create the architecture that they need to create. And like any other structure, if you don't put the pieces of wood together, you don't get a house, you get something crazier. So misfolded proteins is a real hallmark of how cells can go wrong, and that can lead to aging. The ability to clean house, if you will. So over time, proteins get misfolded, and some things get created that don't work out, or they just break, and the cell has to renew itself and actually clean house and clean up messes and do constant upkeep like we have to do on our houses. The ability of cells to do that is critical. And if they lose the ability, which we give fancy terms to, like autophagy, which is literally the cell eats the misfolded proteins. If we lose that ability, that's another way that we lose the ability to renew and be youthful. Yet another is energy. Cells need energy. The battery, if you will, of cells are these organelles called mitochondria. And if the mitochondria do a lot more than just be batteries, but think of them as a battery in your cell that provides energy. If the battery runs down and can't be recharged anymore, you need new batteries, but we're not great at making new mitochondria that are youthful. We can make new mitochondria that don't work as well as they used to. So mitochondrial biology is another hallmark of aging. So these are examples of ways, if you will, the original hallmarks of aging, where how do cell processes go wrong, and how does that lead to aging? On the emerging side, first of all, science marches on. We're learning more and always, and some hallmarks of aging may be less hallmarky. Maybe they're more consequence than cause. And one example that's been potentially controversial in the aging biology world is telomeres. We've heard a lot about telomere shortening. So is telomere shortening a cause of disease, or is it a marker that bad things have happened? Don't know. But to the extent it's the latter, then maybe telomere shortening isn't as much a hallmark of aging as some of the other things that are more fundamental. But new science will bring new processes in. We'll learn more about how cells work, and there's a constant process on the academic science and thought leader side on what are some of these other things we're seeing cells do, and could they be hallmarks of aging? The other way that I like to think of hallmarks of aging, though, is to get out of it's about cells, but it's not all about cells. Aging is, as you said, is sure, people should care about their cells, I guess, but it's pretty hard to tell people you should think about your cells. You can definitely tell people you don't want wrinkly skin, right? Do this. But if you say you don't want to lose your autophagy, so do this, that's a harder sell. But aging is so much more than cells. What about intrinsic capacity? What about vitality, which let's make that more biologic? Muscle strength, the ability of your muscles to recover after exercise and self-renew and be strong. What about your senses? What about cognition broadly and biologically? It's not just about neurodegenerative disease. Are there ways in which we could look at the biology of the aging brain and ask, can we enhance cognition biologically and to embrace, if you will, those as hallmarks of aging too, worthy of the same scientific treatment, worthy of the same focus, and worthy of therapeutics development.
When you're looking at the complexity of all of this stuff, how do you think we're going to be able to begin weeding through this stuff? For me, AI feels like the closest thing that we have to a magic cure. So if any sufficiently advanced technology is indistinguishable from magic, I would say that we're getting pretty close to that. And we're filming this not long after the firing of Sam Altman and the near immediate rehiring of Sam Altman. And there is a lot, who's the CEO of OpenAI. And there is a lot of debate about whether their new thing, I think called Q Star, is AGI, and that spooked everybody, and that's why they fired him. And this is really a battle around safety. But what do you think about that? How much of a difference do you think AI is going to make? How much does that fall into your investment thesis? And as all the things you just laid out are incredibly complicated, and it feels like we're sort of at base camp of Mount Everest, and we have a long way to go. Does AI feel to you like the elevator to the top of Mount Everest that it feels to me?
For me, AI is a tool. It's a great tool, potentially, used well, like any tool. Harnessed and exploited and adapted, I think AI is already an important tool in drug discovery, and can be even more important. To your point, it's possible for folks like me to make things sound real complicated, but at the end of the day, the way we make progress is by breaking things down into doable tasks. Take that hill, take the next hill, take the next hill. I don't stay up at night thinking this is hopelessly complicated, I'm drowning. Rather, it's how can we address this question to answer that question to make that thing work. So that becomes then a set of addressable problems, a set of addressable puzzles. And AI is a remarkable tool for reducing complexity. It's one of its best things, one of its best, most validated uses. And to reduce complexity in what's a hallmark of aging and what's the connection between autophagy and wrinkly skin, that's where AI is having a role today in our world, and will have a really big role tomorrow. There's no question. So is it the elevator from the base camp to the summit? I'd say it's the fixed ropes. You get to the next level, and instead of being presented with, oh boy, it's windy, it's really steep, I'm afraid I'm going to fall off the mountain. Oh, there's a rope. I can grab onto that and pull myself up and guide myself along. Now I'm feeling more sure-footed.
I like that. That's a good analogy. So let's talk about those questions that we have to ask and answer in order to get where we want to go. Do you have a sense of what they specifically are?
The goal is to make it linear. So you're suggesting perhaps that there's a linear process. We figure out the biology, that translates into mice, that translates into people, and that translates into drugs, which translates into prevention. The goal is to make it as linear as possible.
But what are the specific linear steps?
So looking at the early side, we really need to understand as much cell biology as we can. Answer the questions about how these hallmarks of aging work together, how they interact, how one leads to another. And importantly, can we not just ask, if we stop this bad process, will cells get better? Because we know the answer is yes. But rather to ask, if we intervene late, there's already some damage. Because how do we know? We know that we're getting a disease when there's either a sign or a symptom. So can we use that biology in whichever hallmark of aging one wants to talk about, or whichever biologic process, mitochondria, fibrosis, whatever it is that you want to do, can we find ways to start when the damage has not become permanent, but already started, and move things backward? So that opens up a whole set of inquiry at the early science level. Professors in labs, entrepreneurs in labs, asking fundamental, basic questions about how cells work. That doesn't look like a drug yet. And there's a lot of work happening in that area, and we need to have more of that. We at Hevolution are funding new and emerging scientists to ask questions that we don't even know how to ask yet. But we want to know if we can intervene, if we can make mitochondria work better, if we can restart autophagy, if we can restart the process of unfolding and refolding misfolded proteins. So there's some very specific sets of basic questions that scientists and labs need to answer. Then, really important are the questions about translation. We never could go, and we never will go from, even with AI, even with the best AI, from we predict this chemistry will do this in a cell. Let's put that in 5,000 people and see what happens. No, there's some stuff we got to do in the middle. We certainly have to do our best to predict whether it will be actually useful, and importantly, whether it will be safe. So that's where translational science, animal testing, and the whole chunk of moving from discovery to development happens. So we know there's a whole bunch of questions that are pretty standard. Every pharma company, every biotech company asks questions like, if there's a model of a disease in a mouse, does this therapy make the mouse better or not? Those are useful, those are important, but we need new questions, new models. We really need new models, because aging isn't a disease that is A or B, on or off, 1 or 0. It's a process. So we need to be thinking in some ways linearly, but less statically, about biomarkers, about predictive models. Again, AI can help us ask some of those questions, and maybe even can help us design organs on a chip so that we can iterate more cheaply in that, is this likely to be safe? Let's make some predictions.
When you say organs on a chip, are we talking purely we map out the way that a given organ reacts to given chemistry?
Sure.
Is that the punchline? Is it's basically just pure predictive? This is how a liver works.
So that is actually a pretty useful tool. Yeah. I think when people talk about organs on a chip, they talk about that. They also talk in a more physical way, literally taking cells, putting them together, and helping them, encouraging them to interact with each other, to be not just a cell. Okay, a cell, we study it. Now we're going to make a prediction about a human. What lies in the middle are groups of cells, cells communicating with each other, cells working together. That becomes tissues, that become organs, that become people. So organ on a chip also is not just a predictive, an in silico, if you will, a computer predictive process. It's also a whole set of approaches today of taking groups of cells, putting them together, and studying them in a more systems way, asking what they can do as a group, and putting them to work to ask questions then about chemistry and stuff. So literally creating mini organs, sometimes called organoids, and making them functional to answer questions, so we can have a model now in between cells, worms, and mice, actually model how organs might respond to aging or therapies that can interfere with that.
Okay, there's something very, very intriguing here. Let me ask you, do you think we live in a simulation?
I'm thinking about this for a second.
I am going to say I'm already surprised. I thought you would give me a shoot from the hip answer that no, of course not.
All right, here's my answer. One of the things that makes humans demonstrably different from other organisms on the planet are we have consciousness and we think. That's a good thing, but it gets us in trouble. And partly it gets us in trouble because thinking outside of your own head is really hard. It's hard personally, it's hard professionally, and it's actually hard scientifically. So in that light, we do create by looking at all the experiences we've had, all the knowledge we've learned, all the things we've learned from iterating and experimenting and doing well in jobs and messing up in other jobs and watching other people do well and mess up. We think we know some truth. We say, this is my approach. This is my approach to science. This is my approach to interpreting those data. We've all heard there's lies, damn lies in statistics. Well, we can convince ourselves that data is showing us a bunch of different things. And in that light, we are living in our own heads and we are creating the simulation that we live in. We can't, or it's very, very hard to say, I'm going to step back from my ground truth assumptions about what this experiment should show or what that drug should do and actually be open to looking at what's really happening. That's super hard. If we can do it even a little bit, breakthroughs happen. People make breakthroughs in their careers. They make scientific breakthroughs and insights. They invent new things. So in that light, we are living in a simulation that we create in our heads. And the interesting thing is everyone's simulation isn't exactly the same. Do I believe that there's objective reality? Absolutely. I'm a scientist. I believe in objective reality. There are facts. And in that light, because if there weren't, if we were truly living in a simulation, it'd be probably a lot easier to develop drugs in the matrix than in the real world where biology is messy and we don't know everything. So
I don't think there's a difference. So I'm on the record of having said that we don't live in a simulation, I don't think. But I've said many times what you just said, which is there really a difference between being trapped in your own mind and living in a true objective simulation? It is a fact that the human brain is encased in total darkness. And yet, as I look at you, it doesn't feel like that. It feels like light is hitting my brain and I'm simply seeing what is there versus electromagnetic signals being processed by my brain and creating a sense that I'm seeing something. But given that we see 0.00035% of the available electromagnetic spectrum, we know that we are oversimplifying the world grossly. And it becomes a question of, okay, well, if I'm simplifying it, then my brain is making decisions about what to show me and not show me. It's interpreting what it sees and what's the interpretation. All right, I want to set that aside for a second. And even though I don't know that I believe this, I'm going to make my best pitch for that we really do live in a simulation. Okay, it goes like this. And the reason that I was thinking about this is you were talking about AI and the complexity of all this and being able to build organs in silico, that meaning on silicon chips. It's a fancy way of saying that it's a computer simulation. So I spend the vast majority of my time building video games, which is not something people know much about me yet, but they will if I have anything to do with it. And what you begin to realize is you can create a relatively simple set of procedural rules, and from that is born an incredible amount of complexity. And so many of the most played video games, and the one I will use, have you ever seen Minecraft?
yes,
Okay. Oh, I love this. Okay.
I've got a daughter. I've got nieces.
Amazing. So you know the drill. I have had the good fortune of encountering Minecraft very late in my life, so I don't take it for granted. So when I encountered Minecraft, I was like, what on earth is this incredibly complex universe that I've stumbled upon where everybody gets their unique seed? And as you explore the world, you realize it's more and more complicated. I got tired of being blown up by what are known as creepers. And so I looked up online, like, how do you keep the creepers away? And it was like, put a cat in a boat. And I was like, what? Like that was, I had not seen a cat and I did not understand why you would put a cat in a boat. Anyway, what I began to realize was from a relative, I mean, compared to biology, Minecraft is stupid simple. But from this incredibly simple set of rules comes an unimaginable amount of emergent complexity. And as I was playing the game, I realized I was explaining to some of my teammates how I play, and they're like, that's not how most people play Minecraft. And I was like, whoa, why? And so anyway, you begin to realize not only is there emergent complexity, but then the behaviors of the people engaging with this simulation also have their own emergent ways of playing the game that weren't contemplated when the rules were set forth in motion. Now, given then that you can create from procedural rules, you can create something of near infinite complexity, that to me feels so analogous to the way that life is. And I think the mistake that people make when they're assessing biology is they mistake unknown for unknowable. And I think that biology is knowable, even though it is very complicated. And even though right now we know so very little and therefore are able to make so few predictions, as AI becomes more complex, the reason that AI is so powerful and the reason that I consider this the elevator to the peak of Mount Everest is that what we have not been able to figure out yet are the patterns that emerge from the simple set of rules. Once we can identify the patterns, we can work backwards to the simple set of rules. But if we can't figure out the patterns first, I mean, this is like Newton's laws of motion, which then Einstein obviously refined upon, but by discovering simpler and simpler equations. So my hope is that what AI will be able to do is stop being tricked by the apparent complexity of the emergent behavior, and it will be able to ascertain the simple set of rules that give rise to these patterns. But it has to be able to parse through these patterns first. So when I look at, okay, one, I want to get back to that the set of questions that you pose that we have to be able to ask and answer in order to truly tame biology. Okay. So we have to ask and answer these questions to really be able to control biology, to do what I think we will be able to do, which is extend human life indefinitely. Now, I would like to introduce, for people that don't know the Dunning-Kruger effect, so that people don't waste time saying that this is Tom in the grips of this, which is true, by the way. All right, the Dunning-Kruger effect is you know so little, you think you know a lot. I completely acquiesce. I know so little, it feels like I know a lot. But this is where I think that we can start to, I think that embracing the Dunning-Kruger effect is the right first step to embarking on a very complicated journey. And I think that it is actually useful to try to connect dots that may not connect in the end. And this is something that I look for in entrepreneurs. Can you create a narrative that allows you to have a direction that you're moving in, and at the same time question your own narrative because you know it's wrong? So what I'm about to lay out, I know is wrong, but it's going to allow me to move in a direction. Okay, so here are the questions that I think we have to answer. What causes aging? That's question number one. If we understand what causes aging, then the question becomes, can we reset that process? If we can reset that process, then can we solve for persistence? The reason I think persistence matters is the only reason that humans care about each other, about themselves, is there is a continual sense of identity. So I love my wife. My wife, even though she's changing over time and I'm changing over time, we have a sense of persistence. So I have a sense that I have shared my life with a continual entity. I have a sense that I am a continual entity in all of that. Now, the reason that I think that matters is right now, there is an organism on Earth that is truly immortal, meaning unless it dies a violent death, it will never die. And that is this jellyfish. The thing is, the jellyfish, to renew its process, it has to basically de-differentiate all of its cells back to a pluripotent state. So it basically becomes a amorphous blob that then reconstitutes itself back into the jellyfish. Now, I'm going to guess that if it had memory or whatever, which it probably doesn't, but if it did, that would all be wiped out in that process of becoming pluripotent again and then reconstituting itself. So that feels like, again, fully embracing the Dunning-Kruger effect, that this is way too simplistic, and we will find over time that I'm just not getting enough into the nuance. But that gives us something directional to work with. That what we have to figure out is, what is aging, which I think we've covered, which aging is the epigenome beginning to break down, not mutations in DNA, but the way that we bookmark our DNA so that the cells begin to lose focus. And as the cells begin to lose focus, then we age. We see all the things that we think of as aging. But to fix that, we would have to remove all of those things, which we have shown. The Yamanaka, forget his first name, won the Nobel Prize for showing that you could bring a cell back to a pluripotent stage. But I have a feeling if we did that to the whole body, that we would de-differentiate to the point of nonsensical, like we would cease to be the same organism. And so we have to be able to solve for that problem if we actually want one organism to live forever.
So, some great topics to unpack there. In no particular order, I believe you're correct. Can't prove it. I believe you're correct that if we could become the jellyfish and actually piece by piece, or as a whole organism, truly reprogram ourselves all the way back to the beginning, we would, this is the metaphysical part, I'll get to the biologic part in a second, we would almost certainly be resetting our brain, which would necessarily reset our consciousness, which would necessarily wipe out all those memories and all the things that we thought of as life. So, speaking just for me, look, I'm not ready to die. I got a lot left to do in life. I got decades. I'd love to live a really long time. But am I willing to say that sacrificing everything that I've seen, done, and felt in life to make my liver last forever? No. We're humans. We're not jellyfish. So that's personal. That's philosophical.
I think everyone would agree with you, including myself.
On the AI part, it is a fascinating topic, and applying this tool, but also this approach to thinking about aging, thinking about drug discovery, thinking about medicine is a fantastic topic. One of the things, the reason I call AI a tool and not sort of the solution, it's a tool, is at the end of the day, as far as I know, and I don't know everything, AI has to work with the data set that it's presented with.
Not anymore.
Okay.
They're now creating synthetic data sets. This is one of the big potential breakthroughs.
Fine, no problem. But they are someone's creating the synthetic data set.
The AI is creating the synthetic data set. Now, it's spun off of the original.
I'm going to assert that my point isn't yet. We may get to the part where my point is vitiated, but I'm going to assume that my point's still valid. At the end of the day, the algorithms are working from a set of ground truths that they have to be presented with. They're not making up ideas. Now, if and when algorithms start making up ideas and saying, if that were true, then this might be true. And I'm not sure if it's true, but I wonder if this thing could happen. That's getting closer to what happens with humans. But let's assume for the moment that at some point, at some fundamental level, there's a set of facts that are taken as ground truths by the algorithm to spin up, to reduce complexity, to make predictions, and even spin up synthetic data sets. what's never in that world, what's never going to go away is the need to create more ground truth, to actually make observations, to make living things, to take biology and actually ask questions that yield new pieces of data. We need more data. We know that if we're building AI algorithms, if we're building neural networks, they love data, right? They get better and better the more data you feed them. They want more data. We still have a lot of data to create. We don't know. We know a lot about the epigenome. We don't know everything. We don't know all the observations that create those fundamental, simple sets of observations and rules that you spoke about. So in Minecraft or a game, any game, you can set up a set of facts and create enormous complexity from it. I fundamentally believe we haven't observed all the fundamental facts of biology yet, and therefore we're not going to put scientists out of business. We have to do experiments. We have to make observations. We have to be curious and say, I wonder what would happen if we did this. What would that show? And be surprised. If we were never, once we stop being surprised by every experiment, then AI can take over. But until then, we're creating new pieces of information that will change those algorithms, that will change the predictions, that will change the synthetic data sets. So we can't stop doing that real basic piece, that real fundamental, let's make observations about aging and biology. And that's the engine that will drive the whole thing forward.
What is it you think humans will always be better at than AI?
The list is getting shorter, but I do think the word that keeps coming to my mind is curiosity. I think humans have a remarkable capacity to say, I wonder what would happen if. And I understand that you can certainly program a computer to try every simulation possible. That's a little different than making a choice that, to your analogy of put a cat in a boat, that's going to save you over here. We could never see the path to that. We could never figure out from first principles why the cat in the boat means you're not going to get your head chopped off at a different place in a different chapter in a different part of the game, even if in retrospect it seemed obvious. But this is different. This is the imagining why, without knowing, without having any logical reason, why would we go ask that question? Why would we try that thing out? That's what humans are really good at. And there's something about intuition that's real. It's not a random process. I don't think scientists are essentially Brownian motion, just randomly doing experiments and every once in a while.
Brownian motion? What's that?
Essentially random motion of subatomic particles, electrons just kind of vibrating around, molecules vibrating around.
Do you think we live in a determined universe?
Again, there's an objectively correct answer of yes or no. I don't know it. I choose to believe that, like a video game, the outcomes, the complex outcomes of the basic rules are somewhat predetermined. But unlike a game, we can change the rules. That's where science comes in. That's where intuition and imagination
comes in. Are we changing the rules, or are we just discovering more of what's already set in stone?
I think there are some rules that we can't break, we can't change. I think we all used to think that was Newton's laws, right? There's a speed limit in the universe and it's the speed of light. Except, I don't know, we'll find out. Maybe it's not all the way true.
But that's discovering something that already exists versus changing it.
At one level, I agree with you. At another, because humans are built off of those rules, if in fact there's something we can learn about, and I'm not a particle physicist, so I'm way over my skis here, but let's just say we discovered an ability to we discovered that light doesn't go always in a straight line. It can be bent into a curve. Okay, fine, we discovered that. But if we could harness that, then we could absolutely be changing the rules by which bodies move in space, by which speed limits in outer space are constructed, and by analogy to something we care about here, change the rules of how diseases start, progress, and maybe go backwards. If we can discover something, sure, that exists, but then manipulate that to make aging not a linear process, but a curved process that maybe can curve back upon itself, that you don't have to want to live forever. That's just a very pragmatic approach to totally changing the game on how therapeutics work.
Do you believe you can violate the laws of physics?
I know that I cannot violate the laws of physics.
Okay, so when you say change rules, what do you mean? Because when I think of rules, the rule set to me of how everything in life works, including biology, is the laws of physics. And the laws of physics, I'm going to guess, end up being relatively simple. And from that emerges the incredible complexity.
Sure.
But there is no changing it. There's discovering it. And once you understand it, then you can harness the power. But I don't think Einstein changed Newton's laws. I think Newton just had an incomplete understanding of physics. Einstein got closer, but even Einstein died not fully understanding physics. We still don't fully understand physics. So it's not that I think we're changing things. I think we're discovering it. Now, I don't know if this is core to your thesis and I'm just hung up, or if it's core to your thesis, then we need to debate it. If it's not core to your thesis, I will relent. But I am very much hung up on the idea of changing the rules.
Oh, okay. Well, let's see if you agree with this. There's rules and there's rules. It may be that the speed of light is the speed limit in the universe. It may be. That's a rule. There's also a rule that the speed limit on I-280 in Cupertino is 65 miles an hour. You can choose to break that rule, and there may be consequences or there may not be consequences. But you wouldn't have been able to break that rule if cars could only go 20 miles an hour. You had to learn more. You had to discover more in order to create cars that could go 80 miles an hour. And then you have a choice to break the rules. So do I think that there are fundamental ground truths in the universe? I actually do. I don't know who created them. I don't know what they are, but I think they exist. But how they get implemented and the rules by which not just we choose how fast to drive, but the rules by which literally our organs interact, our body ages, are, I actually think, they're built on those ground truths, but there's a lot more rules that come into play to create a body, to create disease, and to approach treating disease. So if we know more about those rules, we can, I think, break some assumption. How about one way to bridge the gap between this rule conversation is if we replace rules with assumptions. We assume we know how humans work. We assume we know how to treat cancer. We assume that we can't reverse fibrosis. Well, that's true given the rules we know. But maybe we discover something and that says, oh, we can break that rule. But we had to put a cat in a boat. We had to give people vitamin E. We thought it wasn't good for you. Then we thought it was good for you. But now we're giving people vitamin E and it's doing this thing, and that changes something. So I do think that we can change the rules of the game in medicine, but we need to know more to do it. And we need to use tools like AI to actually reduce the complexity so we don't just randomly try stuff.
Do you think the AI is going to be able to learn to speak in DNA?
Probably. I don't see why not.
What will that look like?
At some romantic level, I suppose it could be creating life. It could be changing the nature of life. It could be changing how our brain works. But in the more mundane way that things seem to work out in our world, what it's likely to do is to predict with far better certainty how to prevent damage to DNA, how to repair damage to DNA. I think it will work, and I think it will have a real impact, for example, in cancer.
In what way?
I think that I don't know how far off this is, but I want to believe it's in our lifetime that using AI, we will be able to create tools, and by this I mean probably molecules or some version of a molecule, that can crawl down your chromosome, look at your DNA, find areas of damage, and like repairing the ties on railroad tracks, repair them before the train comes and gets thrown off the rails. That is not possible today. People like to talk about it. It's not possible today. We don't have a molecule that can crawl down your DNA and find the right damage to fix very specifically. We take holistic approaches. We give drugs that affect your whole body. Even gene editing, which sounds pretty precise, we know that edits are created in places other than where you want to make the edits. Now, we're pretty robust, and that hasn't led to wholesale chaos in people, but there's consequences. Every drug that works has negative consequences at some point. So I think AI will help us to create tools that are much more dynamic in that sense.
As we start targeting the different therapeutics, whether it's cell therapies, whether it's gene editing, what do you think is going to be the consequences of that over the next, let's say, decade? Do you have a near-term target that you think that we're going to be able to meaningfully hit? Is it life extension? Is it health span extension? What do you think is more near-term?
In the spirit of breaking big problems up into solvable chunks, I think in 10 years, there's no question that we're going to have discovered some more of those fundamental, simple ground truths that create the complexity of biology. We're going to understand some things that we don't understand now. We won't have observed them yet, but we will. And we will use that to look at, in a new way, the approach to some diseases and to some processes that lead to disease. So in 10 years, we'll know more in a fairly fundamental way. And two, we will apply that to new sorts of approaches to a variety of diseases of aging and processes of aging. That, I think, for sure. That's the chunk that Hevolution can bite off today. Now, we're focused on much more than just that. We're looking beyond 10 years. We're looking at the long term. What that turns into, what that 10 years worth of work turns into, is new therapies in development for new definitions of disease. So that's where we get to some of the interesting things that really people care about, that affect, what happens when I go to the doctor today, or how do I think about going to the doctor? I think within 10 years, we'll think about going to the doctor differently. We will start to really move from, if I feel good, I don't go to the doctor. Oh, I feel sick, I go to the doctor. Now it's kind of too late for a whole bunch of things, but we can try to stop or reverse whatever bad thing is happening today. But in the intervening time, a whole bunch of things have happened to us that we probably didn't want to have happen. Mm-hmm. I think we will, within 10 years, start to really see a shift to thinking about our health as a continuum, to saying that story in our mind, I don't want to look in the mirror and see wrinkled skin, so I'm going to put sunscreen on today. We're going to be able to take that approach in so many more ways, not because it's a good idea, but because we'll have actually shown people that it makes a difference. I think that's what That's what we need. That's what we need to do to make that leap. Is it's one thing to say, eat your vegetables, get enough protein, exercise, get enough sleep. We all know those things are helpful. We all know those things have a meaningful impact in your health span. And yet we don't always do them, in part because it feels hard, but in part because I want to see tomorrow the results of what I did today, not I want to see in 30 years the results of what I did today. So we're impatient. We all are. We should be. I think within 10 years, we will start to really see this fundamental research into aging biology start to yield both opportunities for drug development, but also approaches to treating people that will give people more of that aha moment in a relevant time frame. And so it will seem today, what seems today sort of unnatural for a lot of people to think about, well, if I do the right things today, I'll be better in 30 years, but tomorrow I'm just going to feel tired or that I didn't get that donut or whatever. To give them something that they can feel, maybe not tomorrow, but next year they can see. And that's where we talk about this geeky thing. We need biomarkers for disease. We need to be able to do clinical trials and have intermediate outcomes, things that we can measure in blood that will predict diseases of aging later. But they're more important than just clinical trials. They're important for people because of just as today, we can measure your cholesterol and say, gee, your cholesterol is really high. We kind of know that if you don't do anything, you're going to be at higher risk of this later. So really, we should do something about it. We need more of those. And aging research will give us more of those things to work with. And to the extent we can show that they're predictive, that they help us break some of the rules, then we'll have a mindset of, I want to do these things today, whether it's take a supplement or make a lifestyle change, or go to the doctor and say, let's do a survey of the aging diseases that I might be susceptible to, and not just feel depressed about it, but have something to do about it. That's what we can do. I think we can move there. We can start moving there in 10 years. And over the next 20, 30 years, which isn't that long, we'll really have some things.
And so it's my understanding you guys are funded for 20 years. At the end of that 20 years, what would you expect the average life expectancy to be? And before you answer that, I'll give you some stats. In 1900, the average life expectancy was 47 years in the US. As of 2023, the average life expectancy is 79 years. That's an increase of almost 70% in 100 years. What do you think we can do in the next 20?
I'll give you a couple answers to that. One, left in a relatively perfect world with people going to the doctor and doing all the right things, that average lifespan will inevitably inch up. It will, because we'll take care of ourselves, we'll edit ourselves to the extent we can, we'll prevent chronic disease to the extent we can. And an average life expectancy will move up. Now,
by what percent? So over the last, 5 or 6 years, it's been 0.08% per year, with a couple down years thrown in the mix for good measure, but pretty small amount.
I was going to add that what can change that is we can do things to ourselves that will definitely lower that number. So I can't give you a prediction for what the average lifespan will be in 5 years, because I can't tell you whether we have created a new pathogen that wipes us out, or whether we've all decided to stop exercising, or whether, for that matter, we cure diabetes. Like, those are things that will meaningfully affect these curves. Back to the speed limit idea, though. Personally, and frankly, Hevolution isn't concerned with, in and of itself, for its own purpose, extending the theoretical maximum lifespan. There is some presumably theoretic maximum lifespan. We humans haven't lived beyond the 120s. There's probably some number, and I don't know what it is, That is in the absence of a wholesale jellyfish-like restarting, some point at which basically something stops working and beyond our ability to fix it. So there's some theoretic maximum lifespan. I don't know that we're going to change that in 10 years or 20 years. We might. It may or may not be important to do so. It's vitally important that we change health span, the percentage of our lives that we're living in relative health as opposed to relative decline.
Why is that vital?
That is vital because average human lifespan is extended from 49 to 70 something. True. But today, 1 in 3 people is living with multiple chronic diseases. 20% of people living with, I think, 3 or more. And that number is going up, not down. We're spending a larger percentage of our time living with chronic disease. So we're adding years, but in one sense, to what end? Now, as an individual, look, if you live to 90 and fall off Mount Everest right before the summit at the age of 90, you probably feel like you had a pretty good life. But if you live to 90 and the last 30 years of your life, you're in and out of the hospital, you have multiple diseases, you can't do the things you want to do, you can't work. That's no good for you. And it's also really no good for society and civilization. The big picture, the biggest picture is across the planet, people are living longer. That's good news. Also, fertility rates are dropping. People are having less babies. And you put those two things together, and I'm not editorializing. I'm giving the news, not the weather. That's just true. As that happens, a whole bunch of the assumptions on which we've built everything have to come into question. We've built everything we do on the assumption that there's lots of young people eager to get into the job market, and they're productive and make money and support older people. And then there's older people and they kind of leave. What happens when there's fewer young people coming into the job market, into the productivity market, broadly speaking, and more people not leaving? Well, one thing we got to think about is, I'm not an ageist, and I'm not accusing anyone of being an ageist, but are we kicking people to the side of the curb at 65 and saying you're done? Well, we know we're not doing that. But to say something more rational, how are we ensuring that as we age as a people, that we can remain vital, productive, working, producing, paying taxes, all the things that we want to do? Well, if we're sick and have multiple chronic diseases that impoverish us financially, emotionally, and physically, we're not going to be able to do that. So it is, in my mind, absolutely vital that we improve health span, because I need it, you need it, children need it, and society needs it. We have to keep people productive and vital. We want it. That one doesn't need to extend the theoretic maximum lifespan to do that. It's a different approach. We have to stop the ravages of aging without having to stop aging itself. And that's what we're really concerned with. And that, by the way, is where I think we can have real impact in the 10, 20, 30-year time frame. We can make a real impact here if we do it, if we bring together scientists, investors, companies really exploiting the science that we're discovering, and other stakeholders. We have to deliver this to people, and we certainly can't be having a mindset that, well, we'll figure out a way to do this for one person at a cost of $1 billion. I mean, that's exciting, I guess, for that one person. But this is we're a civilization that's global. We're societies that are global. And Hevolution is absolutely concerned with global accessibility. So we need solutions that are broadly applicable. But if we can do that, and I'm sure we can, we'll have an impact globally that's really big. And it's going to take all of us. It's not, I mean, Hevolution is really set up to be a convener, a catalyst, to bring attention to this, to put capital to work at the pain points, and to jumpstart and bring in additional capital. And that's across the value chain, if you will, from new scientists with new ideas to starting new companies, which we're going to work on, to investing in companies that exist, to bringing more investors into that space and showing them it's a fun pool to swim in and a safe place to invest, and then getting those therapies through clinical trials and thinking about regulatory and commercial frameworks and delivery frameworks to think about prevention medicine more forthrightly than treatment medicine. So we're concerned with all those things. And as we develop, the best way to create that change isn't to browbeat people into believing it. It's to show people why it matters to them, to give them tools that they want to use for themselves. And that means discovering more stuff, breaking some rules, creating new drugs, and getting them delivered to people.
Yeah, I think that is a really good way to get people to care, is to make it tangible in their own lives. Even something as stupid simple as, if you reduce the inflammation in your body, you will feel so different. That's one of the things I wish, if I could snap my fingers and give people, would be just to show them what it feels like to not eat sugar. When you break that addiction to sugar and you no longer get headaches because you're hungry, and you don't get grumpy because your blood sugar has dropped, and you don't feel inflamed and your joints don't hurt, it feels awesome. And you end up not wanting to go back down that path. Another thing, if I could give people a glimpse into, is in terms of getting them to take this stuff seriously. And this is what you were speaking to, but just to say it really concisely, the pyramid's about to flip. So we have always had more young people than old people. And so you had this huge young base, and people died off as they got older, and the retirement age was 65 because 90% of people were dead at 60. And so what you were effectively saying is the vast, vast, vast majority of people are going to work until they die. So you're going to contribute to a system to which you're never going to remove anything from the system. And cool, we're in a good spot. The problem is people keep retiring at 65, but they live to 79, you now have a problem. And as we increase the chronic disease burden that people are able to carry, now all of a sudden you're staying alive, but as you said, you're in and out of the hospital, you're a massive drain on the system. And I'm going to be directionally correct, if not precisely accurate, when I say in something like the next 10 to 20 years, 2/3 of our GDP will go to healthcare. That is completely unsustainable, especially when you look at the debt crisis that we're in now. This is fun to have this conversation with you, somebody that really understands the macroeconomic climate. And so getting people to understand that this isn't just a health crisis of the disease burden that people are carrying due to modern lifestyle, but this is also an economic crisis when you've got so much global debt. You've certainly in the US, you've got so much money printing, known as monetizing the debt, where we're basically saying, it's all good. We'll just keep printing, literally making them up, more dollars, more dollars, more dollars. And you end up in a position where you've got healthcare that's draining your GDP, but you've already got servicing the debt that's draining your GDP. And the only way that you have to address it is to print more money, give people stimulus checks, but you then are constantly flirting with inflation. And as you push that too high, you can obviously end up in an extremely dark position where if you get into even just radical inflation, forget hyperinflation where the dollar becomes meaningless, where you're just at 15 to 20% inflation, that's real nightmare scenario. And now you increase what's known as the Gini coefficient, where you've got the discrepancy between people that are rich and people that are poor just becomes so extreme. And now you have the division reaching really extreme proportions. And so when you look at somebody like Ray Dalio, who, for people that don't know him, nobody has made more money betting on the fact that they understand where the world is going than Ray Dalio. Built the largest hedge fund in the world. He's a global investor. He spent over $100 million just assessing the last 500 years of history and the debt cycle that we go in and how predictable all of this stuff is. Normally, when we get into the kind of debt numbers that we're talking about now, and there is another rising global power like we have, it almost always ends in war. Something like 65 to 70%, it's ended in a hot war. Ray Dalio has upped his estimate of a global war to 50%. When I look at the things that are going to exacerbate that, I know most people are going to put climate as the number one. I'll say debt is probably number one. Number two is going to be the increased burden of Healthspan not being increased at the rate that disease burden becomes a problem. And now you have, because of demographics, you've got this flipped pyramid and you've got no way to combat it. So when I look at what you guys are doing at Hevolution, becomes urgent.
Couldn't agree more. I've often said to my colleagues when they ask, why am I doing this, that the Healthspan crisis is the climate change crisis of human biology. It's that big a deal. I agree. Now, we could look at that and sketch out a fairly dark future. And there are futurists who do that, and it's relatively straightforward to say a lot of debt, emerging powers, a lot more debt, we're spending a lot of money on debt service and healthcare, crowding out other things, drain on GDP, printing too much money. Those do potentially follow one another. So one can walk down the path of that fairly dark future. I have to say, I think one should be, as an investor, very clear-eyed. But to be a venture capital investor, you have to be an optimist. You just have to be. So I look at that and I see tremendous opportunity. I see an opportunity that hasn't ever existed. So let's start with...
What exactly is that opportunity?
I'm going to tell you. Let's start with people. People are living longer. And we keep talking about the problems of chronic disease. I think about it every day. But what about the opportunity in that? People do live in their own heads. Our minds evolve just as our bodies do. And as we get older, assuming we can keep up with cognition and we don't get neurodegenerative disease, we know that, for example, things that we call judgment, wisdom, get better as you get older. Now, we know that the frontal lobe, which is important in humans, is one of the things that distinguishes humans from primates, isn't fully developed till you're 30 or 40. So as humans live longer, there is potential for human insight and human capacity that we haven't fully unlocked yet. So there's things that we can't predict. What would happen if our workforce were made up of people with quantifiably more wisdom and judgment than it is today? I'm not dissing the workforce today, but that might unlock some pretty interesting opportunities. So I think there's opportunity to affect the macro by addressing Healthspan. Also, to come back to the dark economic future, look, I worry about those things too. On the other hand, to take off my biologist hat for a moment, the US dollar is backed by the full faith and credit of the United States government. It's not backed by gold in Fort Knox or silver in Nevada anymore. So to the extent that it's really important that we believe that the United States is the most productive nation on earth and the biggest engine of creation of wealth and opportunity and productivity on earth, which it is, to the extent we believe it, then we live it. Just as when you start a company, the chips are all stacked against you. But people do it because they believe and they work hard, and all of a sudden, maybe not all of a sudden, maybe it takes a little while, They build stuff and create stuff. We as a people in the United States can keep creating stuff and building stuff, focusing on actually doing real things, and that becomes reality. That becomes the strength of the dollar to an extent. And then, of course, people around the world have to believe it for the dollar to continue being the reserve currency of the world. That's important. I personally, there's something we haven't talked about yet. I personally am not as bullish on cryptocurrency as some others are, because I actually really like the dollar being the reserve currency of the world. I like people believing the United States is something special economically and productively, because I really don't want to see people saying we don't need dollars anymore. Because then that dark future of we got a lot of debt, it's going to get bigger. There's $52 trillion of unfunded pension and retirement mandates globally as it is today, and the bottom of that iceberg of debt is not going to get smaller as we get older. That becomes more of a real problem, not a theoretic problem. If we say, well, currency doesn't matter, all those dollars are just pieces of paper, that's a problem. And I don't want that future. And I don't think we're condemned to that future. I think entrepreneurs, regular folks, people go to work. In the real world, people go to work, they're productive, they buy houses. We need to make sure that opportunity is available as broadly as possible, for sure. That's not just a good idea, it's really important. And we need to make sure that people continue to believe that there's a reason to keep doing those things. And if we do, I'm actually pretty optimistic about our economic future as well as our health future.
Seems pretty inevitable that the economy will right itself eventually. The thing that I don't think people take into consideration is that economic bloodshed cares not about the individual. It's perfectly happy for there to be a 10, 15-year period of just absolute agony for everybody. And then you come out the other side and you're fine. Like even if there is a hot war, the hot war will eventually end. And so the bad news is that going through that, even a 5-year period when you're living it on the ground, is an interminable amount of time. It's just unbearable. And given,
look at 2008, for sure. Much less. I mean, sure, the Great Depression, but we don't remember that. We weren't there. We were there for 2008, and it was really scary and really painful, and it didn't care who you were. I agree.
Correct. So my thing is, look, I don't think it takes any energy to be pessimistic. I think it takes a lot of energy to be optimistic. I think optimism is the right place to put your energy. As a 20 plus year entrepreneur, I know what it means every day to wake up and be like, wow, the odds are stacked against me. And yet I'm going to show up and just play my guts out. But at the same time, I have learned as I have gotten older and wiser is that to understand the context you're living in so that you can play the game well. I think life is a winnable game. That isn't just money, but money is a part of it. And anybody that blinds themselves to that, I think, is very foolish. And so to understand where we are in what is really a pretty predictable cycle, I think is very important. No reserve currency has lasted much more than 100 years. And depending on where you start the clock, we're somewhere between 70 years and like 115 or something. So it ain't going to last forever. So now let me ask you, you brought up crypto. I didn't know if you'd be well-versed in crypto. Do you think, even though I know you don't want it now, do you see it as an inevitability? And if it is not an inevitability, what is it that draws people to it now in this moment, even if they're just the obscure?
You said the most correct thing just now that you've said all day. I am not an expert in crypto. That is absolutely true. With that in mind, I didn't say I don't want it. I think it exists, and I think it has a role. The future that I'm not excited about not sure whether it's going to happen or not, but the future I'm not excited about is that sovereign currencies become irrelevant and that only crypto matters. That presents, I think, a lot of uncertainty and upends a lot of assumptions on which all of us are living our lives that could be a pretty big, pretty terrible displacement. So I'm not anti-crypto. I'm anti a future where nothing matters because I'm an optimist. Now, what's the attraction today? Gosh, that's a great question. I think to some people, it's getting something for nothing. I'm going to go mine Bitcoin and I'm going to essentially get something for nothing. Gold rushes are relevant. Humans are attracted to that. Okay, we're not going to stop that. But let's remember, in the gold rush in 1849, very few prospectors got rich, but many enduring fortunes were created by selling picks and shovels. So as currency is digitized, as national barriers to economic activity continue to fall, irrespective of any government wanting to change that, let's pay attention to who's selling the picks and shovels. How do we create an ecosystem that allows for crypto to exist and create opportunity from that? And I don't have the answers because I'm not an expert, but I think that's attractive to people and should be, and attractive to entrepreneurs. And there are things beyond exchanges that can be created and built, businesses that can be created and built that encompass and maybe even improve digital currencies. So that I think is attractive and interesting.
Yeah, crypto to me is a very interesting use case. I'm intrigued by your reaction to not wanting there to be no sovereign currencies. I don't know how I feel about it, is the honest answer. I'm very much not just rip the Band-Aid and go entirely to cryptocurrency. I think I like living in the US. The US is predicated on a strong government, having power that they can project into the world, being financially strong. All of those things are amazing, and I love it the most, and I'm perfectly happy to have a government. The problem is going back to how much of this stuff is predictable. So humans work in a certain way. Again, just to bolster my own argument that we're living in a simulation, we are born of a simple set of rules. And because of that, human behavior, there's a great quote, any one man is, this is a paraphrase, any one man is a mystery, but as a totality, they are a mathematical certainty. I think any individual human is near impossible to predict. But when you step back, all of a sudden humans become really predictable in their behaviors. And there is yet to be a government that did not print their way out of problems. And eventually that stops working and you just get so much debt that there has to be a reset. And we are so perfectly marching down Ray Dalio's 6-phase cycle, the sixth phase being total collapse. Ray Dalio puts us in phase 5.5, which is so deeply disconcerting. But it seems pretty self-evident given the amount of debt that we're taking on. So when I look at that, I ask myself, when I think about crypto, I ask myself one question: will tomorrow be more or less digital than today? And the answer is more, because every kid that's born into a world that is increasingly digital, that just becomes de rigueur for them. It's just, of course, to them, buying an outfit inside of a video game is as meaningful as the outfit that they buy in their real life. That's just self-evident. They don't even think about it. What do you mean? They wouldn't understand. Like, oh God, I forget who said this, but their kid asked them for V-Bucks, which is the dollars inside of Fortnite. And the parent was like, why do you want that? It's not real. And their answer was, what do you mean it's not real? It wasn't even like a challenge. They just didn't understand what they meant by the statement. And so as that happens, those kids will then raise kids that are even more digital than they are. And as things go digital, everything we care about, including money, is going to become digitized. Now, the question is, what's a darker future? where the government controls the digital currency and they can track every dollar you spend. And if they don't like the way you've done something or spent money, they'll just stop you. Or one where it's censor resistant and no one can stop you. Now, the bad news is people in crypto want me to be, oh, crypto is seizure proof. It's not. It might be seizure resistant, but if a government comes to me and says, I'm locking you up forever unless you give me your code, I'm giving them my code. So I don't understand people's pushback on that. That is self-evident. So, but it is harder for sure to censor, and I think that is ultimately a good thing. But I also don't want a world that just flips on a dime. The slower the transition, the happier I will be. It just gives everybody time to acclimate. Have you been paying attention to what's going on in Argentina?
A little bit, yeah.
Be very interested to see how this plays out. Like you, I have not paid super close attention, but one of the things that the guy that was just elected cites is that basically when you monetize debt, you are stealing from people. And so with all the money printing going on, something like 2/3 of all the money that's ever existed was created in the last, I don't know, whatever, 3 years. It's really pretty startling.
Well, look, I think what we really need, speaking of living in a simulation, I think we need Thomas Jefferson and Alexander Hamilton to come and take a look at this and give us their perspectives, right?
Can you channel their perspective?
I don't know that I can, but I'd really like to hear it. We were, of course, this conversation happened in the early 20th century around the gold standard. You can only print as many dollars as you have gold, because someone decided gold was valuable and important. And then we changed our mind. And to your point, I guess it works until it doesn't work, but it really worked. So no debt isn't the right answer. Infinite debt isn't the right answer, which would tell someone like me that there's some optimal amount of debt, and one can look over time and say, oh, too much debt, not enough debt, monetizing debt. Those are all good arguments. I agree with you, though, that one of the great things about humans and civilization, with some notable course corrections, it sort of moves forward. We're not going back to the gold standard unless something really bad happens. And we're not stopping the digitization of currency unless something really good or really bad happens. So I agree with you. The question is, what do we do about it? How do we adapt to it? Not unlike climate change, I guess you got two choices. We can say, thanks, Earth, it's been great, and create civilization on Mars. Or we can figure out how to adapt to the reality. The climate's changed. The climate changes. It gets warmer, it gets colder, and our biology is a little bit fixed in time. We can't evolve to be heat or cold tolerant in the extreme in 20 years, but climate's going to change. It is changing. So how do we adapt? How do we use technology to adapt? How do we create technologies to adapt? How do we look at big picture things like, can we moderate the rate of climate change? All important, but changing the trajectory of the warming of the Earth from 1 degree centigrade to 0.75 degrees centigrade to 1.25 degrees centigrade. Okay, if it goes too fast, we don't have time to adapt. If it goes slow enough, we have more time to adapt. I like that, but I presume that if we could truly stop and reverse climate change, we'd pretty soon be talking about an ice age, and that wouldn't be so cool either. So it's all about, can we adapt? Currency is going to get more digital. Governments will seek to assert control over that, just as they seek to assert control over banking transactions of dollars. And we have to adapt. We have to right-size policy, and we have to adapt technologically and economically and personally to that digitization. And that's where I think it gets interesting.
All right, you talked about slowing things down. not wanting change to happen so rapidly we can't adapt. Talk to me about if we're going to try to reach longevity escape velocity, where for every year that we live, technology adds more than a year to our lives. What lifestyle interventions should people be doing that will have the biggest impact and help them live not only healthy, but as long as possible?
Well, it's a great analogy. So back to why does it matter to you today? It matters to you today because if you do things today that we think we know work or do know that work, essentially what you're doing is buying yourself Healthspan time for technology to catch up and do some things. So just like if we can slow down climate change, we buy ourselves more time to adapt. If we can slow down the unhealthy aging process by using tools we have today, we buy ourselves time for Hevolution to make all the investments it's making, for the ecosystem to deliver more knowledge, develop more therapeutics, create preventatives. We need time to do those things. So what works today? Unfortunately or fortunately, I think it's a lot of things that we know. We can start anywhere. Getting enough sleep. When we sleep, our bodies do all sorts of incredible things, and sleep researchers are finding more and more incredible things that happen when we sleep. It's the opposite of a passive process. It's actually just as important as being awake. We've learned that when we sleep, aspects of our immune system get turned up. So there's a circadian rhythm that when we sleep, our immune system is like, okay, he's sleeping. Let's go fix some things. Let's go find some inflammation to quell. Let's go find some infections to treat. So sleep is important. It's hard. We give up sleep voluntarily for work, for recreation, but sleep's important. So get enough sleep. Nutrition. My wife is in food banking, and is far more of an expert on clinical nutrition than I. But ultra-processed foods, not so good for you, in ways that we're only really understanding today. Now, a little bit, of course, a little bit's not going to hurt you. Human beings are the most resilient species. It's amazing what we can kind of do to ourselves and do well with for a while. So a little bit is fine, but wholesale replacing replacing a diet with ultra-processed foods, we know is not good for you. And the more science learns about it, the worse it looks. You mentioned things like food composition. Are we eating, forget ultra-processed or not, are we eating more sugar and carbohydrates, more proteins and fats, more vegetables, no meat, some meat? Good news, the human body can adapt to a variety of diets. Most fad diets work in the short term. None of them work in the long term. But fundamental approach to healthy mix of real food makes over the short term makes you feel better. That's good news. And over the long term, there's almost no question it's good for you and good for slowing down aging processes. So those are some basics. I'm a fan of an appropriate amount of exercise. Humans were to either steal a line from a sports book or a Bruce Springsteen song. We were born to run. We don't have to run, but we were born to move. Our brain may or may not our brain loves it, may or may not require it. We could, in some, I think, dystopian future, actually live in the Matrix and just be brains hooked up to water baths. But we like our bodies. We use our bodies. Our bodies and our minds work together. It likes a little exercise in whatever form and amount works for you. So those are some basic things. I am not here to push a supplement or even supplements in general. I think that to the extent that we are missing micro and macronutrients, which happens because of life and the way we make food, then replacing what we're missing is important. I think the jury's out on whether giving supranormal amounts of supplements, big pharmacologic amounts of supplements, is always good, always bad, or sometimes good. It's going to take a lot more clinical research. That's where things like drug repurposing comes in, where looking at drugs like metformin or rapamycin that in the longevity world have a lot of currency, but looking at them objectively, it makes sense. There may be something there, but I don't think we're going to be at a place where there's a magic pill that everyone takes that's a poly pill that replaces good nutrition, sleep, exercise, basic things that don't eat too much sugar. I don't think we need that future. I don't think we want that future. I don't think that future is actually possible. I don't think there's a magic pill. And then there's paying attention to the primary and secondary prevention, to use an epidemiologic term, that we know. We know that if someone has known heart disease, they really need to pay attention to things like lipid levels and cholesterol. We know that. That will save people's lives. It might save your life if you've had a heart attack and you have really high cholesterol. It could save your life. Now, 35-year-old healthy person thinking about, can I buy a house? Is inflation too high? What's my job? How's my relationship with my spouse? They may not be thinking about their lipids, but primary prevention has a role too, at least getting checked. So getting people into really a mindset of, we should be in a preventative mindset today. We know enough that people should have a preventative mindset today is true. Now, what sometimes gets confusing is we do epidemiologic studies and say, if you're 35 and healthy and your cholesterol is 175, you might have a 0.001 increased chance of something someday. That's pretty abstract. It's pretty hard to interpret that for my present and my future. And it kind of feels like there might be some pros and cons in there somewhere. So that's complicated, but it's worth having the discussion, because only by having the discussion will you find out if you're at really big risk, or maybe you're kind of doing okay and you just need to do more of what you're doing. But let's have that conversation. Let's get people to think about their long-term health as something worth checking in on today, just as we encourage people to start saving money for retirement early, even if it feels like you're giving up spending some money today. We really want people to do it, and there's all sorts of good reasons. So I think those are some real basic things that we give lip service to and we spend some effort on. But if we could really cause change, if we could really get people to think about that the way they think about putting a seatbelt on when they get in a car, right? That was a social change that saved a lot of lives that wasn't inevitable. We introduced seatbelts, we mandated them. It wasn't obvious that everybody would comply and kind of unthinkingly wear seatbelts, but it's been a good thing. So how do we get that?
Speaking of things like seatbelts, I know you know about vaccines. Vaccines have now become very controversial. How should people be thinking about vaccines?
I can only tell you how I think about them. And you might expect someone like me to say, all vaccines good. Well, vaccines are complicated. And the answer is, it depends. There are diseases that are preventable with vaccines that have been in millions and millions and millions and millions of humans, and that have contributed meaningfully, really meaningfully, to that increase in lifespan that you talked about. So one of the things that lifespan didn't march up from 49 to 79 just 'cause. It marched up due to clean water, antibiotics, vaccines, and a couple other things. But vaccines are in the mix. There were a lot of kids that died of a lot of bad diseases that still exist that don't die because of the basic childhood vaccines. They're safe. They're effective. I don't think that people can have a conversation about it, but boy, that stuff's really good for you. It's really good. It's responsible to do for your children and your family and for yourself. Now, where it gets interesting is a new vaccine for a new disease. We don't know everything about the disease. We don't know everything about the vaccine. In order to create vaccines quickly, we use new technology. So we have new disease with somewhat, some predictable and some unpredictable effects on people short and long term. New vaccine, which stimulates your immune system to interact with that disease in some predictable ways, maybe some unpredictable ways. New technology that is really great, but we don't know everything about it. So now we got three unknowns. Think about that complexity thing. We now have three unknowns in like 3 dimensions that we've just been hit with all at once. Making predictions about the future for you as an individual in that environment, pretty hard to do. I wouldn't stake my career in saying what's going to happen to you tomorrow if I do this to you today. That's a tough one. So are all vaccines good? No, there's been lots of vaccines that haven't worked out in the clinic or in people. One example that I can think of, having been raised in New England in the US, is Lyme disease. So Lyme disease, real problem. First Lyme vaccine was developed. It did what it was supposed to do in terms of stimulating the immune system against the bacteria that causes Lyme disease, but it didn't really work out because people got reactions to it that were complicated and had something to do with the interaction of the human body and that bacteria and the vaccine that you could only figure out when you gave it to a lot of people and kind of did the population experiment. We don't like to think that we're being experimented on, but we're doing experiments on ourselves all day, every day, right? We're eating ultra-processed foods. We're doing an experiment. What happens if you do that? Is it good or bad? We're, flying around and exposing ourselves to cosmic rays in airplanes. Is that good or bad? Turns out it hasn't really caused a problem, but could have been something that would be a problem. So vaccines with a capital V are not all good or all bad. And there's nothing like the tincture of time and data to help determine better who should get vaccines, when should they get them. You're right, they become really controversial, and COVID was an incredibly difficult, scary, painful, challenging, expensive time for the planet. But take a step back. It was an emerging disease. It is an emerging disease, but it became an emerging disease that we were worried might wipe everybody out. Let's not forget that was a legit worry that people had. We got to do something about that. The best tool we could think of was develop a vaccine quickly. It's been effective. It's become controversial in part because if you ask people to do something based on statistics, none of us are statistics. So that's been true throughout history. That's not a COVID-19 vaccine question. That's a human experience question that we've always had. Why should you put your faith in this thing? Well, on average, you'll be better off if you do. Okay, but what about me? How do I make a prediction about whether I will benefit or be harmed by that? It's impossible to answer with certainty. The more data we have, the more precisely we can answer, the more confidently we can answer. But we were, in a really scary time. The best tool we could think of was create vaccines. Those vaccines did what they were supposed to do what they're supposed to do. It seems clear that they were, broadly speaking, super effective. We probably avoided millions to hundreds of millions of deaths. And if you're one of those people that would have died and didn't, you're pretty happy, I got to say. You can't necessarily know if you were one of those people, but there's probably a few 100 million happy people because of that. Now, there's some unhappy people. Take the vaccine, you didn't get sick. Well, see, I didn't need the vaccine. Or did the vaccine prevent your disease? Never know. Can't play the game twice. So it's hard. I'm sympathetic, even as someone who's invested in a vaccine company that developed a life-saving vaccine. I'm sympathetic to both sides of this conversation. I just think it's really important to remember that at the end of the day, it's not politics. At the end of the day, it's not belief. At the end of the day, it's, are we doing the best we can do to keep the most people safe and healthy for the longest period of time? And if we have enough goodwill towards folks who are doing that, then we move forward. And if we lose goodwill towards people doing that, then it gets harder to keep doing the things that we're trying to help people with.
I know people are going to ask in the comments, where do you get the estimation of 100 million people alive because of the vaccine?
So I don't remember the exact number, but the U.S. CDC has done modeling around this, and I could certainly find the epidemiologic modeling. It's actually, I think, way more than 100 million. I think the estimates based on what the case fatality rate before there was a vaccine was, what the case fatality rate after the vaccine, the rate of spread. Now there's again, one could kibitz over this because, well, but there were all those social interventions. Did they work? Did they not work? Leaving all that aside for the moment, because I don't know, right? I don't know whether social distancing saved a lot of lives or didn't save a lot of lives. It's not my area of expertise. A lot of heat and passion around that.
Yes.
I'm talking about vaccines, and but people have tried to tease out just the impact of the vaccines, and I think the estimates are pretty high for the number of lives it probably saved.
The thing I'll be very interested to see, there's a guy named Gary Brecka who is convinced the insurance industry is going to downrate people that had the vaccine. I don't know if he's right, but that is certainly a very interesting metric to pay attention to over the next couple of years. Do they see patterns in the data that indicate that it helped, didn't help, held steady? I'll be watching that closely.
Well, the insurance industry is either the most important industry we've ever created or the most evil industry we've ever created.
Interesting. Give me the case where it's the most evil.
Well, you're asking people to bet on something that hasn't happened. That's what insurance is, right? Homeowners insurance, you're asking people, what's your quantification of the bet that your house is going to burn down? Now, health insurance is a little different. Health insurance is probably an oxymoron, right? We're not insuring against bad health. We're financing healthcare. That's a whole different story. But insurance is essentially a bet in a market where there's no real product and it's unclear who has. I mean, the insurance companies have the best data, actuarial tables about this. So, do we need it? I mean, it's pretty intangible. We need food, clothing, and shelter. As you pointed out, we need money to do stuff. But do we need insurance, or do we want insurance, or have we created an environment where the perception of need of insurance? I don't know. But that's the case, that it's not an unfettered good is there. Now, Lloyd's of London would say, well, no, I mean, commercial shipping wouldn't happen without Lloyd's of London insuring cargo ships. They're probably right too. I'm just saying it's not an unfettered good. It's not an inevitability. Insurance companies downrating people, presumably for things like life insurance, based on did they get a COVID vaccine? Well, insurance companies downrate people for smoking. Pretty darn good evidence that if you smoke for 30 years, 40 years, a pack of cigarettes a day or the equivalent, you're pretty much more likely to live a shorter and simultaneously more expensive life than if you didn't. And that's fair. There's really good data. Now, insurance companies rate people on all sorts of things that we know about and don't know about. Are all those ratings fair? Doubtful. There's no doubt. We know that insurance companies rate people on social decisions, really social decisions. Auto insurance. if you are married versus unmarried, your car insurance is cheaper. But does everybody get married? Should everybody get married? Should you get married so you have cheaper car insurance? Is that what the insurance industry wants? Is that right? I don't know. But they do it. Do we have enough data to rate people's long-term likelihood of dying a more expensive death because of COVID vaccines? Of course we don't. We don't even know what the pros and cons of the vaccine are over a 10-year period, much less a 100-year period. So I can't stop the insurance company from doing, or any insurance company from doing it, but I'm not sure it's going to, that rating would be based on things that you and I would agree are super rational and great sets of data.
Bill, this has been amazing. Where can people follow you?
I'm on LinkedIn, and Hevolution's on LinkedIn. I'm on Instagram, although that's more about cute pictures of my dog and food we've cooked. But we're there.
But Bill Greene.
I'll get it to you. It's W Greene, WGREENE. And I'm definitely on LinkedIn through Hevolution for sure.
I love it. All right, everybody. Speaking of things you will love, if you haven't already, be sure to subscribe. And until next time, my friends, be legendary. Take care. Peace. If you enjoyed this episode, be sure to check out this other conversation with Peter Diamandis. For those that take the time to understand the most likely path forward, there will be huge opportunities. To help you better navigate what's coming, I bring you futurist Peter Diamandis.